Okay, so here we go on number 11. They have a table for us here, and they want us to figure out if a function is linear or if it's exponential or neither. So how do you know? Well, basically you look at what's happening over here with the y values, and you ask yourself if it's what it's doing. Well, it's multiplying by 7 every time, isn't it? Multiplying by 7, multiplying by 7. You can check that last one even on your calculator. It's multiplying by 7. So if it's multiplying by the same number every time, so multiply same number, that means it's exponential. And then how do we find the formula? It's y equals a times b to the x. And the b is the number being multiplied every time. So the b is the 7. And how, so bring it down here. A times 7x. And then, so the b equals number multiplied each time. And the a is the number next to x equals 0 in the table. So that would be, in this case, 1. So this is y equals 1 times 7, not times 7, it's 7 to the x power, huh? There we go. Now, just as a side note, on the test, and the homework, and maybe on the test, we also had linear, so let me tell you about that. It's linear, not exponential, if they add or subtract. If they add or subtract the same number each time. And then that's y equals mx plus b, and the m equals the number add, subtract, and the b is the number next to 0 in the table. That's how you would do for linear, if it adds or subtracts the same number every time. Okay, on number 12 here, we're looking at this polynomial function. So, and they're going to ask us, first off, what are the real zeros? So if I write y, in fact, let's go to a fresh screen. Y, this is number 12, right? Y equals negative 4x squared times x squared minus 2. Okay, get rid of that. So how do you find the zeros? Well, you gotta factor it all the way down. So this is going to factor x minus root 2, x plus root 2. So first factor completely. So we factored it the rest of the way. Now, find out, we're trying to find the zeros. So the zeros, which are the same thing as the x-intercepts, they're synonymous, same thing. How do you find them? Whatever makes the function 0. So what could I plug in for x to make that part 0? Well, just 0. What could I plug in for x there to make this part 0? Positive root 2. And what could I plug in there to make that part 0? Negative root 2. So those are my zeros. 0, root 2, and negative root 2. Any of those x values will make the whole y 0. So they're going to be x-intercepts. So on the graph, so I'm going to have at 0, at positive root 2, and at negative root 2, I'm going to have x-intercepts. Those are places where y is 0, right? If you plug those in, they make the whole function 0. So it's at a height of 0. So let's go back to their question. So they want 0, root 2, minus root 2. Those are the zeros. Type them, and now they want the multiplicity. What is multiplicity? That's the power. So they're looking for the power. So for the x equals 0, he came out of this. What's the power? 2. So his power is 2. This guy came out of this term. What's the power there? 1. Power there, 1. So that's the multiplicity. So we would have the 0 has multiplicity 2, the root 2 has multiplicity 1, the negative root 2 has multiplicity 1. Okay, and so then they want to know, what does that mean? So if this one is even, because it's 2, this is odd, and this is odd, because they're both multiplicity 1, right? So multiplicity 2, multiplicity 1, multiplicity 1. So an odd power means what? Means the graph is going to pass through at that point. And an even power, like 2, means it's going to bounce at that point. So that's what they want. I don't think they use the words bounce. I think they say just touches. That's what they say. I forget their word. They mean it just touches it. And instead of pass through, they call it crosses. Crosses through the graph, touches the graph, and crosses through the graph. So we go back here and we say the graph of 1 at 0, what does it do at 0? It touches. Touches. At root 2, it crosses. And at negative root 2, it also crosses. Okay, so now the rest of the questions, we're on part C now. The maximum number of turning points. So we had a formula for that. I'll put it over here. Max number of TP turning points is the degree, which is highest power. The degree minus 1. So what's the degree? Well, the degree is if you multiplied it out. In fact, are they asking? Yeah, type the power function. Yeah, so let's do that. So let's find that, and that'll answer everything else. So I called it the end behavior. So the end behavior, they said power function, is if you multiplied this thing out. So if I was to multiply this out, boom, boom, from the beginning, I would have y equals minus 4x to the 4th plus 8x squared, right? So that would be the most important. As you go way off to the right, to like 1,000, a million, a billion, if you're plugging in super big x numbers, all that's going to matter is this term right here. The smaller power terms will vanish because 1,000 to the second power is so much smaller than 1,000 to the fourth power. So for way off to the right and left behavior, all that matters is the most powerful term. And so this is minus 4x to the 4th is the answer they want to the last question, the power function. Let's go over here. So that's right here, minus 4x to the 4th. That's the power function. That's the main power the function has. So now the degree, therefore, is 4. It's this right here. It's the power. The degree is the highest power. So what's the maximum number of turning points? 4 minus 1, 3. So if we go back here, we'd say, 3 is the maximum number of turning points. By the way, what that means about the graph, we could do the graph now. That means this graph is negative in the end, right? End behavior, way over here in the end. The graph's going to go down. Not like a line necessarily. That wasn't very well done. It's going to go down some way or other. And it's going to cross through that point, right? We know it does that. It comes down here, touch that, go back up, cross through that point. See how I knew what it was doing? I kind of just traced it back from the end. So from the end, it's negative. If there's negative in the end, it's going down. If that was positive, I would have made it go up after the last place it touches the x-axis, because I would know it goes up. But it's not positive. The function is negative. What that means is you plug in numbers like 1,000 way off to the right. This term's going to be the most powerful dominant term, and he's negative. So he's going to take that function down, down, down in the end. Then you'd work your way backwards. It's got to hit these 3 points. Those are x-intercepts, zeros we call them, and it's odd here, which means it crosses through. It's even here, which means it bounces, and it's odd here, which means it crosses through. So there we go. There's a general picture of the graph, and we answered all the questions. Okay, so on this one, we've got e to the 5x plus 4 is 14. They want us to solve. So how do we solve? X is up there in the power zone. How do we solve when x is in the power zone? Well, this is what we learned about x, but this is exponential, right? When x is up in the power zone, this is an exponential function. What we learned is that exponentials and logs are inverses. So if you got x up in the power zone, like we have here, and you want to bring it down so you can solve it, what do? You take a log of both sides. Now, what base? Because every log has to have a base. It's got to be the same base as what you have. Our base here is e, so I got to do the same base. Log base e on both sides. We have e 5x plus 4, 14. And when you do that, these guys will cancel, because logs are the inverses of exponentials. So it just cancels out, and you have 5x plus 4. And log base e, what's that better known as? Natural log, right? Log base e is natural log. So we come up here, and we have 5x plus 4 is natural log of 14. They want me to finish solving for x. So subtract 4 from both sides. We get 5x is natural log 14 minus 4. You can't subtract those guys because the 14 here is really inside of the natural log function, and the 4 is outside. They're in two different worlds, inside the toaster, outside the toaster. Last step to get x alone, divide by 5. Boom, so x is ln 14 minus 4 all over 5. That's our answer. That's how they want you to type it in, exactly like that. Okay, so now number 14, it's a log question. They want us to solve a log question. So how do you, to solve for x is inside of a log. I've got to get the x out of that log. How do you get the x out of the log? Well, again, the moral of the story, the theme of these last two sections was that logs and exponentials are opposites. They're inverses. So if you want to get rid of one of them, you do the other. So to get rid of a log, I do a power base, a base to a power. And I got to make the base the same, and then these will cancel because the base on the log and the base in the power match. If they match, then they'll cancel. So what do we have? X squared plus 2. 4 squared is 16. All right, now, how do we solve for x there? Well, we have a couple of strategies. I wonder if it's clear to you. If we have x squared and x to the first with an equal sign, that's not what we have here. There's no x to the first here, notice. But I want to make sure that's clear. That's the one I told you about earlier, where you get a 0, factor, and or use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. That's how you do that. But if you have something like x squared and no x to the first, right? That's what we have. We have x squared and we don't have an x to the first. That's easier. You don't have to do the whole zero factor thing. Just get x squared alone and then do a root and a plus or minus root and you're done. So just subtract 2 from both sides. So x squared is 14, and then we root and plus or minus, because you put a roof on the house, you got to go up and down the ladder. Roots cancel squares. X is plus or minus root 14. Those are the two answers. They want you to type root 14 and negative root 14 as your two answers. Okay, so here's number 15. Now this is a pretty hard problem. These greater than, less than. How do we do these? Let me write out some steps here. So for greater than, less than, or equals whatever, for fractions, when you have fractions with any kind of greater than, less than thing, Step 1 is get a 0 and make the other side one fraction. So first off, I'm going to bring this over. So we'll get 6 over x minus 8 minus 7 over 6x minus 7 greater than 0. So get a 0. Got that. Right, when things jump to the other side, they switch signs. So there's that. And make it one fraction. How am I going to make them one fraction? Well, common denominator. You got to multiply top and bottom of this one by 6x minus 7. And top and bottom of this one by x minus 8. See how the denominators now have the same two things in them? So you can just make it one fraction now with x minus 8 and 6x minus 7 as the denominator. It's common denominator. They have the same two pieces in their denominator. Okay, so what's on the top then? Distribute here. So that'd be 36x minus 42. Now this one's a real trick. This minus sign, he's really on that 7. You don't have to move him, but it might help you. He's really on that 7, right? Because he's on that fraction. So when you distribute here, you'll get minus 7x plus 56. Really easy mistake to make there. Watch out. Okay, so next line, what do we have? It's 36x minus 7x. What's that? 29x. And minus 42 plus 56. It's plus 14. All over x minus 8. 6x minus 7 greater than 0. That's all step 1. Get a 0 and make it one fraction. This is a hard problem. So there's step 1. Let's keep going to the next screen. So I'm going to copy that to our next screen. X minus 8, 6x minus 7. Right. Okay, so now step 2. Numerator equal to 0. Those are x intercepts, and denominator equal to 0. Those are vertical asymptotes. So I got to take the numerator, bring it over here like this, and say, change what I use here. So the numerator, 29x plus 14 equals 0. Solve it. So move the 14 over there. 29x is minus 14 divided by 29. So x is minus 14 29ths. That came out of the numerator, so that's going to be an x intercept. And then the denominator, so you got to take each of these parts. So x minus 8 equals 0. That just means x is 8. And 6x minus 7 is 0. Move that over. So 6x is 7 divided by 6. Boom. 7, 6. Those are both going to be vertical asymptotes on the graph. So let's go to the graph now. So now we're ready to think about the graph. Okay, so now I got to put those places on the graph. So first off, x equals 8. That's going to be way over here. At 8. It's a vertical asymptote, right? And 7, 6. What's that? That's a little more than 1, so maybe like right here. 7, 6. And then minus 14 29. So that's about like minus a half or something. That's about right here. Oh, that's not a vertical. What am I doing? That's just an x-intercept, isn't it? At minus 14 29ths. Okay, so we got a bunch of sections now is what we've got. So step 3 is plug a number in. Maybe I better make it red here. Plug a number in each section to find positive or negative. To find out if it's positive or negative. I want to find out if the graph is up here, or is the graph down there? Is it positive or is it negative? And here, is it up here or is it down there? In this section, up here, down there, out here, up here, down there. I want to find out each of those 4 sections if the graph is positive or negative, above or below the x-axis. So, what does that mean? You got to plug a number in for each section. So, I'm going to take our formula here, and I'm going to plug in. What's the number out here? Like 9. Plug in 9. And so, what am I going to get? I'm going to get 29 times 9 plus 14 over 9 minus 8 times 6 times 9 minus 7. Well, I want to make this as easy as possible. Look at that top. That top up here, that's positive. That's all I care about is the sign, because in the end, I just need to figure out if this thing's positive above or negative below. 9 minus 8, that's positive. And 6 times 9, 54 minus 7, that's positive. Positive over positive times positive, that's positive. So that means what? That means the graph, here, let me go with a different color maybe. The graph is, certainly up here with the vertical, and I don't know what it's doing. Somehow it's above. It's up in that area. Okay, let's go to the next section. I'm going to plug in something between these guys. What's something between there? Well, how about just like 7 or 6 or 5 or 4 or 3, anything in that section. I'll plug in 7. X equals 7. This other one was plugging in x is 9. So plug in 7 back here again. So 29 times 7 plus 14 over. Plugging in 7. So I'm plugging in 7 here, 7 here, 7 here, right? 7 minus 8 and 6 times 7 minus 7. So what does that equal? I don't know. That's positive on the top. This part is negative, huh? Negative, and this part is positive. So positive over negative positive. That's going to be negative overall, right? If you have one minus sign, you're minus. So that's negative, which means what? The graph is down here. It's going down by the vertical asymptotes here, and it's negative in that whole section. Right? Did you see how? Let me make sure that you're good with that. Did you see that? So one more time. This top up here is certainly positive. 7 minus 8 is certainly negative. And 6 times 7, 42 minus 7 is certainly positive. So one negative sign came out negative. Let's go to the next section. I need to check right here. How about 0? It's a nice easy one. Let's plug 0 here, here, and here. Can I just do it quick? I'm going to get positive on the top, right? 29 times 0 is 0, plus 14 is positive. On the bottom, I'm getting 0 minus 8, negative. And 6 times 0 is 0 minus 7 is negative. Positive over 2 negatives? So that equals positive, doesn't it? So that means this one, this graph, is up here. It's positive. And then it's going to hit right here at 0, isn't it? Everybody good there? Makes sense. I probably should have left that blue. So I checked 0. Maybe I should have stayed with my green color here. I checked, I plugged in 0, and it came out, positive over 2 negatives, which is positive. So the graph is going positive up in this section. All right, last section, one more. So it's kind of tedious. Got to pick a number out here. I don't know, like how about -10 or whatever. You know, this is like -1/2. You divide in your calculator, so even -1 would work. Yeah, how about -1? How about I just go look, -1? That's somewhere left because it's about -1/2. You divide in your calculator. So -1. I'll plug in -1 and see what I get. So plug in so come back over here, here, and here. Plugging in -1, -1, -1. What am I going to get? Well, this is going to be -29 plus 14. That's negative on the top. On the bottom, -1 minus 8. That's -9. That's negative. And 6 times -1. That's -6 minus 7. That's negative. 3 negatives. Negative. So that means the graph is going down over here. It's going up here. So it's negative. So there. So we have the graph. Basically, we've graphed the thing. Okay, so what? How do we answer the final question? Well, they're going to either ask you to give them as the answer the places that are above 0 or the places that are below 0, positive or negative. Above 0, positive, below 0, negative. What are they asking for? Look back here. They want, whoops, I kind of scribbled that up. They want greater than 0. That was the original question. Well, that was the question after we got 0 on one side. Greater than 0. So greater than 0 means positive, doesn't it? They want the positive areas. Where's the function positive? Well, right here. That'd be in this section. And right here. That'd be in this section. Those are the two sections where the function, the graph, is positive. So how do you say that? Well, that's between minus 14/29 and 7/6 united with, get this out of the way here, this section which goes from 8 to infinity. 8 to infinity. Parentheses on all those because we did not have an equals bar. It was just greater than. Plus you can never touch vertical asymptotes. So let's go see if they have that answer. Is it A here? -4, oh, no. I did the wrong thing there, huh? What is it again? -14 unites to 7/6. Yeah, this looks good. And then 8 to infinity. Yeah, there it is. All right, we good there? One more, number 16. X cubed minus 64x. Oops. Was it greater? No, less than or equal to 0. All right, so how do we solve it? Well, it's kind of like the last one because it's greater than, less than again, but it's easier. It's not a fraction. So step 1, so when you got greater than, less than equal to, greater than equal to. So step 1, so it's not a fraction. So you just, same thing, get a 0. We've already got that, and factor. We don't have to make, it one fraction. We've already got a 0, so just factor. How do you factor this? Take out an x, like that, and then you can factor more, x minus 8, x plus 8. So there it is, step 1, get a 0 factor. Step 2, each part equals 0. So what will make this 0? X is 0. What will make this 0? X is 8. What will make that 0? What can I plug in for x? -8. Each part equals 0. Those are x-intercepts, and then you just, well, here, let's put that on the graph now. So we're going to have a graph, and at 0, at -8, and at +8, you're going to have x-intercepts. And so now we just need to figure out, get a basic graph. Where's the function above? Where's the function below? So now there's two ways you can do this. You can plug a number in each section like we did on the last one, Or for these kind that don't have vertical asymptotes, right? Not fractions, you can do something easier. You can just find the end behavior, positive up, negative down, by the highest. Oops, I'm kind of scribbly here. The biggest power term when multiplied out. So if you multiply it out, it started multiplied out, so the biggest term is x cubed. Positive x cubed. That means up. That means in the end, this graph for sure is going up, 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 because it's positive. And then you can just do the pass-through bounce stuff. Remember how we learned that? This term has a 1 power, 1 power, 1 power. So it means it's going to pass through, pass through, pass through. Remember what we learned about that? If you have an even power, if one of these was like 2, then an even power bounces. Remember we talked about how, like, if you have an even power like x squared, remember that graph bounces. And if you have an odd power like x cubed, that graph passes through. Doesn't it? That one passes through, this one bounces. So yeah, even powers bounce, odd powers pass through. So you look at the power on each individual term. I'm not talking about this most powerful term anymore. That we're done with that. That determined the end behavior. That was a positive, so it's up, up, up on the end, at the end. I'm looking now at the individual x-intercept terms. And I'm saying, what's the power on each of these individuals? They're all 1. Just going to pass through, pass through, pass through. It won't bounce in any of them. So I generally know what the graph looks like from that behavior. So now what do they want? What's the answer to the question? They want to know the places less than or equal to 0. That's negative, huh? Less than or equal to 0. So where are the places? Well, it's right here. It's less than out here. It's less than. So our answer then, let me get these out of the way here. Our answer would be this section and this section. So how do we say that? This is negative infinity, huh? So negative infinity up to negative 8. Bracket, right? Bracket on the negative 8 there, because we had the equals bar. So we want the place where it equals 0 right on, like negative 8. United with from 0, again, bracket to 8, bracket, because again we want to include the equal 0. They said equal 0 right on those spots. So there's the places where the function is less than or equal to 0, negative or right on the money 0. Do they have that answer, or is it just a type in? No, I guess you just type it in, yeah. So there it is.